last time we were discussing about friction on an inclined plane also, and let us understand a couple of examples based on that. So we had seen the important concept that if we have a rough inclined plane of angle of inclination theta, and coefficient of friction mu, suppose, then for any object placed on this, like a block of mass m, what happens is that the component of weight which is normal to the surface is mg cos theta, and the component of weight which is tangential to the surface is mg sin theta. So the normal reaction and the friction, they act in such a way that the maximum friction available to us, which is mu n, or what we call the limiting friction. So first of all, normal reaction is equal to mg cos theta. So therefore we can see that maximum friction available, which is basically the same thing as limiting friction, so that is equal to mu n. So that becomes mu mg cos theta. Okay. So once we understand this maximum friction available, from that we can understand the two situations, that if mu n is greater than or equal to mg sin theta, then the block will tend to remain at rest. Okay. When placed. So in that case, what will happen is that the acceleration of this block will be zero. This will remain at rest, because what will happen is that mg sin theta will get balanced with static friction. So acceleration will be equal to zero, and static friction equal to mg sin theta will act. Whereas, but for that, this condition needs to be satisfied. Okay. Whereas if mu n is less than mg sin theta, if this condition happens, then the block tends to slip. So in that case, in the free body diagram, the type of friction acting becomes the kinetic friction, and the block has an acceleration down the inclined plane instead of acceleration being zero. So here it becomes mg sin theta minus kinetic friction is ma. Okay, so mg sin theta minus mu mg cos theta, because the kinetic friction will be that much. Okay, so the acceleration will come by this formula. It will be g into sin theta minus mu cos theta. So this will be the acceleration with which the block slips if this condition is satisfied, whereas the acceleration of the block will be zero if this condition is satisfied. So just do a review of this concept. It's part of what we discussed last time. Then we'll look at few questions based on this. So if you have any doubt in the free body diagram or the equations we have written, please discuss with me. I will explain to you again. Okay, in these free body diagrams, I'm not showing mg cos theta and normal reaction. They're already there in the top FPD. It's already shown. Yeah, so just take down this diagram with the free body diagram forces shown. This is what we discussed so far. So we started with the discussion of the situation of a block placed on a rough inclined plane. Okay, the two possibilities, that the block might remain at rest or the block might start slipping. Okay, so now let us look at this particular condition a little more closely. The condition of static equilibrium versus the condition of slipping. So for this to happen, for equilibrium, that is no slipping condition, we saw from above that mu n should be greater than mg sine theta, greater than equal to. So that means mu mg cos theta should be greater than equal to mg sine theta. So the condition it gives us on the coefficient of friction is that mu should be greater than equal to tan theta. This is the condition for the acceleration of the block to remain zero. Whereas here, in the second case, the condition for slipping to occur, that is acceleration to be non-zero. Here the equilibrium means acceleration is zero. The condition from above is that mu n should be less than mg sine theta. So that will give us the opposite of that, that mu should be less than tan theta. So mu should be less than tan theta for A to be non-zero, for it to slip. So this is an important value to remember. Yeah. Less than tan theta, slipping occurs. Greater than equal to tan theta for mu, slipping does not occur. Okay. Very soon we'll discuss a concept called angle of repose based on this. But first, let's understand how we can incorporate this in direct problems. So for example, suppose we are given two situations like this. In one case, the angle of inclination is, let us say, 37 degrees. In this case, the angle of inclination is, let's say, 45 degrees. Okay. And the coefficient of friction here is 0.5. And here, let's say the coefficient of friction is 0.75. Okay. And let's also consider another third case where the angle of inclination is 30 degrees. Okay. And the coefficient of friction is 0.7. So let's say these are cases A, B, and C. So we have to find out if a block is placed and released from rest on each of these inclined planes. Okay. In which of them will slipping occur? Okay. Or no slipping takes place? In which of them the block does not slip, or in which case the block slips? This is what we have to do over here. So just try out this question, people. Each of the cases, the angle is given to you and the coefficient of friction is given to you. So you just have to use that limiting value that we discussed in the last one. So you can almost do this orally. So just let me know in the answer key which of them slipping is occurring. Which of them slipping of a block will take place if we place an object. So if it's not slipping, then also find the acceleration. Oh, sorry. If it is slipping, then find out the acceleration also. How much will be the acceleration of the block? So remember, condition for slipping, we place a block on an inclined plane and it starts to slip. The condition for this is that mu should be less than tan theta. And condition for equilibrium, that when we place the block, it remains at rest. The condition is mu is greater than equal to tan theta. Okay. So just check out each of these values here. So in this case, theta is equal to 37 degrees. So how much is tan theta? 3 by 4 or 0.75, and coefficient of friction is 0.5. So you can see what is happening. Mu is less than tan theta. So slipping will take place. Okay, so a block placed over here will tend to slip. So A slipping is taking place. Okay. In case of B also, what will happen? Slipping will be taking place. Let's say this E1, this is E2. Because again, mu is 0.75 and tan theta is tan 45 degrees, which is 1. So mu is less than tan theta. So B also slipping will take place. Okay. Similarly, yeah, Ohm, that's correct. Very good. Third case, you see, when you place an object here, tan theta is tan 30 degrees, which is 1 by root 3. You can take as root 3 by 3 or approximately something like this. Okay. Whereas, so tan theta is approximately this much and coefficient of friction is equal to 0.7. So definitely this is the only case in which you can see that mu is greater than tan theta. So there is no slip. This remains at rest. Okay. Now once you have this, you can use the formula for acceleration. This acceleration is given by the formula g sine theta minus mu cos theta. Okay. So in this case, the acceleration will be g into sine 37 minus 0.5 cos 37. So when you work this out, this acceleration will come out to be g by 5 or 2 meters per second square. Just substitute the values of sine 37 and cos 37. Similarly, here when you work out the acceleration, it will be g into sine 45 minus 0.75 cos 45. Okay, so this will work out to be g by 4 root 2. Okay, so that is approximately approximately 7 by 4. So in terms of g, it is g by 4 root 2. And if you take g as 10, it is approximately 7 by 4, or that is 1.75 meters per second square, close to this. In this case, of course, acceleration is 0. It remains at rest. So these are the values of the acceleration which I've written on top. Okay, so just make a note of this quickly and make sure you understood the calculation in each part. It's very good. No? Okay, people. So hope this question is clear to all of you. Okay, so this is an important concept to remember, that the condition for no slipping is that mu is less than tan theta. Okay. This is the condition for equilibrium, that mu should be greater than equal to tan theta. Whereas if the block is slipping, that means mu should be definitely less than tan theta. Okay. So related to this, there is a term called angle of repose. Okay, there is a definition or a term called angle of repose. So for a given inclined plane which is rough, we define the angle of repose as the angle at which mu becomes equal to tan theta. So for a given inclined plane which has coefficient of friction mu, the angle of repose, okay, so that is defined as the angle of inclination for which slipping just starts. Okay. So that's, let's say, theta r. So tan theta r is equal to mu, or the angle of repose is tan inverse of mu. Okay. So that means for theta less than equal to angle of repose, there is no slipping. The moment theta becomes slightly greater than angle of repose, slipping starts. Okay. So for example, if we have a situation where coefficient of friction is equal to 0.75 and we are asked to find the angle of repose, okay, for an inclined plane with the coefficient of friction equal to this much. Okay, then we'll just incorporate this formula. Yeah, just write down the formula, Rishi. It's very clear. Angle of repose is defined as that angle at which tan theta becomes equal to mu, the coefficient of friction. This is the definition. So for an angle less than angle of repose, there is no slipping. For an angle greater than the angle of repose, slipping occurs. Okay. So basically at the angle of repose, the slipping just about starts. So gradually increasing the angle of inclination, the angle of at the angle of repose, the slipping of the object will just about start. Is it clear? Now just tell me what should be the angle of repose here. All you have to do is substitute in that value. Yeah, anybody got the answer for the angle of repose? It's very simple. Angle of repose should be tan inverse of coefficient of friction. So in this case, it is tan inverse of 0.75. Or in other words, tan of this theta is 0.75, which is the same thing as 3 by 4. So you know that this is a well-known angle. This is 37 degrees. We just saw this angle in the earlier example. So for this particular slope, which has a coefficient of friction as 0.75, the angle of repose will be given by 37 degrees. Okay, now let's move on to some more examples with inclined surfaces, but involving more objects now. So let us say we have this 37-degree inclined plane, and on this now there is a combination of two blocks which are kept against each other like this. So these blocks are placed on the surface in contact with each other initially and released from rest. So blocks A and B are placed in contact and released from rest. Okay. So given that mass of the block A is, let's say, 10 kilograms, and the mass of the block B is, let us say, 6 kilograms, G is equal to 10 meters per second square. Okay. Find their acceleration and any contact force between them if their individual coefficients of friction are. In the first case, coefficient of friction of E is 0.2 and coefficient of friction of B is 0.4. In the second case, coefficient of friction of A is 0.4, whereas coefficient of friction of B is 0.2. So the blocks A and B, assume, are made of different materials. So not only they have different mass, okay, one is heavier than the other, but they have different coefficient of friction, because the coefficient of friction depends on both the things, the material of the object as well as the material of the surface on which the object is placed. So in one case, A and B have coefficients of friction 0.2 and 0.4. In another case, they have zero point 0.4 and 0.2. So in each case, we have to find out how much their acceleration is and if there's any contact force between the blocks. Okay. To start working on this problem, the hint I will give you here is that start with the free body diagrams of the two blocks and try to understand whether they will remain in contact and come with common acceleration, or one will move faster than the other. Okay. So the hint to you is, depending on the coefficient of friction, you will see that either A accelerates faster than B, so they lose contact, or B is pushing against A because it has a tendency to accelerate faster, and in that case they are remaining in contact and they are coming together. So either they will be coming together with B pushing against A, or A will be accelerating faster than B and they will lose contact. Okay, so one of the two possibilities is there. So you have to understand from the given coefficient of friction that which of the two possibilities is occurring and therefore how to solve. So you want me to scroll up? Okay. All right, we'll come back to this question. Just finish writing this one first. Okay, now start working on this problem. Okay, people. So let's understand how to approach this question. So as we are discussing that, when we release the two blocks here, one of two things can happen. Ya to the situation will be like this, that they will be coming down together with common acceleration. So this is one possibility, that okay, they will have one common acceleration. With actually what will happen is B will be pushing A forward with some kind of normal force, and A will be pushing. So they are in contact as this slide. Okay, this is one possibility. Okay, and the other possibility is that they lose contact because A has a faster acceleration than B. So that's another possibility that can happen. And you'll realize there's no third possibility. It has to be one of these two, because the coefficients of friction are different. Okay, so in this case, what is happening? Acceleration of A is becoming greater than acceleration of B. Okay, so the distance between them keeps growing, and they lose contact. Okay, but obviously this cannot happen. That acceleration of B cannot be more than acceleration of A, because B is the one which is behind. Okay, so we have to understand which of the two cases occurs in the given situation. Okay, so the most important thing is that if B has a tendency to accelerate more, has a tendency to accelerate faster, okay, then case 1 will occur. Okay, that is B pushes E. Whereas on the other hand, if A has a tendency to accelerate faster, okay, then case 2 will occur. Very simple. Okay. So now we have to just gauge that in which case which of the two things are happening. Now one thing you'll see, any block which is kept on a surface which has a coefficient of friction less than tan theta, its acceleration, how it depends on mu. Its acceleration depends on mu by this formula, g sine theta minus mu cos theta. Okay, so that means the larger the value of mu, okay, the lower the acceleration. जितना ज़्यादा mu का value है, that much lower will be the value of A. So that means for this condition to happen, okay, that B has a tendency to accelerate faster than A. B has a tendency to accelerate faster than A. What is the condition for that? B should have a smaller coefficient of friction. Okay, so for this to happen, coefficient of friction of B should be less than coefficient of friction of A. Then only B will have a tendency to accelerate faster. Whereas if A has a tendency to accelerate more than B, then what should be the condition in terms of coefficient of friction? Coefficient of friction of A should be less than coefficient of friction of B. Okay, so now you can go back to this above thing and understand which of the cases what is happening. So in the first case, in part A which I had given over there, okay, let's just pick up those values. This is what was happening. So now based on this principle or this concept here, in this case what will happen? A has a coefficient of friction which is less than B. So A will block A will accelerate faster than B. So acceleration of A will be greater than acceleration of B, and they will lose contact. that is case 2. Whereas in this case, B will push A. They will accelerate together in contact. So now at least we know what is happening in each of the cases. Now we just need to calculate the accelerations and we need to calculate the contact force in the second case. So for that, you come to the free body diagrams of each of the blocks in each of the cases and work this out. Yeah, Idanshu, that is decided on the basis of the values of coefficient of friction. Na? See, over here we have written down that when the coefficient of friction of B is less than A, then which one is happening? Case B is happening. So in which case it's less? In the second case, no? Here it is 0.2 and this is 0.4. So this is which case? This is case 2. So this is what will in this part what will happen is case 1. And vice versa for this. Here it is mu A is 0.2. So coefficient of friction of A is more than coefficient of friction of B. So that's why they'll have a tendency to separate. A will have more acceleration. Okay. So now that you've understood in which one of the two which cases are happening, next make the free body diagrams for each of these parts. For part A and part B, next thing what you do is make free body diagrams to calculate the accelerations and contact force. Okay. For that you need the masses also. So remember the mass of A was given to us as 10 kg and the mass of B was given to us as 6 kg. And the angle of inclination was 37 degrees. Take G as 10 meters per second square. Okay. So use all this data, okay, along with the values given. Okay, very good, Kunj. That's correct. What about the first case? Have you worked it out? Yes, very good. That's correct. Okay, so let's work out this question next. Okay, so they will lose contact. So in this case, you can just directly use the formula only. No? Like if you remember the formula, you can directly use this. Okay. Or otherwise, you can just make the free body diagram. And from that, so you can see that so solving equation 1 and 2, you get this formula. So in case you don't memorize this formula also, you can just compare these two equations and solve it. So anyway, so here when you numerically substitute, this will come out to be 10 into 3 by 5 minus 0.2 into 4 by 5. This is 10 into 3 by 5 minus 0.4 into 4 by 5. Next step, these values. So acceleration of A is coming out to be 4.5, so 4.4 meters per second square. And so that's what's happening in this particular case. When the coefficient of friction of A is 0.2 and the coefficient of friction of B is 0.4. Now next, we look at the B case, where coefficient of friction of A is 0.4 and coefficient of friction of B is 0.2. So in this case, acceleration of A will be equal to acceleration of B, and they will be in contact. So B pushes A with contact force N, let's say, not equal to 0. Yeah, then you just follow the calculation. I've taken the denominator common outside, so that's why. Otherwise, you can directly write this also like this as 10 into 0.6 minus 0.16. That will also give you the same thing. Yeah, that's not a problem with Anshu. That's okay. Uh, as long as the calculation is clear to you. Okay. So just verify both the answers. Make sure you understand the calculation yourself also. And if you finish with that, then work out part B. Anybody else got the answer for part B? Kunj, your answer is correct, but anybody else has got the answer? And also the normal contact force. Achha, yeah, that's correct, Kunj. Rupesh, the acceleration is correct. Yes. Check on the normal reaction force once more. Okay, so let's look at the free body diagrams and the answer for the second part. The second part, because the coefficient of friction of B is less than the coefficient of friction for A, they are accelerating together as we have already written above and remarked. Okay. So what is happening? They are having a common acceleration, and this one is pushing against this, and this is pushing back. So some kind of contact force like this is acting. Okay. So in this case, it's easier to make the individual free body diagrams for each of the blocks. So we look at the FBD of the block A. The forces on it are components of its weight. Okay. B is pushing it down with some contact force. Obviously normal reaction and also some kind of frictional force. Okay. Which will be mu A into the normal reaction. Now all this together is giving it an acceleration of A like this. Okay. So for the block A, the equations are becoming n plus mg sine theta minus friction is equal to mass into acceleration. And oh sorry, and the normal reaction due to the floor on A or due to the inclined plane, that one is Na. That's this. Okay. So we substitute this here, we will get this equation that n plus n plus mag into sine theta minus mu a cos theta is mass into acceleration. So with this we can substitute the values. So n plus 100 into 3 by 5 minus 0.4 into 4 by 5 is equal to 10. So we get n plus, this will become 3 minus 1.6, right? So that is 1.4 by 5 into 100. So that will become 28. So n plus 28 is equal to 10. This is the equation that we are getting from the block A's free body diagram. Okay. Now similarly, we can make the block B's free body diagram and write an equation for that. So for the block B, the contact force is like this, okay, whereas weight's components are like this. Normal reaction from the ground is like this, let's say, and friction applied by the surface on B is mu B into NB. So we have NB is equal to this, and we have minus friction minus N is equal to mass into acceleration. That's acceleration. Okay. So once again, substitute this here with the value that Okay, so this becomes this. Okay, so this time when you substitute, this is 60 into 3 by 5 minus 0.2 into 4 by 5 minus n is equal to 6a. So we will get, this will become 60 multiplied with 3 minus zero point 0.8 by 5. So 12 into 2.2. Okay. That is the same thing as 60 multiplied with so we will get this as 26.8 minus n is equal to 6a. So this is the second equation that we are getting from here. Okay, by the free body diagram of the block B. Now we can solve these two equations to find out. So equation A plus B, for example, will give us 26.8 plus 28 is equal to 10 plus 6a. The acceleration will become 54.8 divided by 16, which is equal to yeah, that's correct. Okay. And we can also substitute this here to find out the value of normal reaction. So this is the acceleration, and the normal reaction will be 34.25 minus 28. That's 6.25. Okay. So these are our final answers. No, that calculation is correct. So you can check it out. $26.4 it should. Oh, I've written it 26.8. My mistake. It should be 26.4. That's correct. This value here. So just make small correction here. Yeah, so this will become exact actually. 3.4. Okay, so just note this correction to the answer. Normal reaction will be exactly 6 newtons and the common acceleration will be exactly 3.4 meters per second square. Thanks for pointing that out, Ruksan. Okay, so anyhow, hope the question is clear now. Okay, so let's move on to another type of situation involving friction now. So hope this is clear to all of you. Okay. Now we come to what is called the two block type of problems or two body type of problems. Okay. So you will see plenty of these type of questions in your both in HC Verma as well as your module. So we have two blocks placed like this, one on top of the other. So now this horizontal surface of the floor, this one is smooth. but this surface has a coefficient of friction mu. Okay, and initially the system is at rest. Now a horizontal force F is applied on B. Okay. Find the accelerations of A and B given. So take down the question first, then we'll discuss more about how to approach this. So initially the system is at rest and then we start applying some force on B like this. So we have to find out two cases, one where the force is 30 newtons, the other where the force is 15 newtons. Okay, so okay, now see, based on the amount of force we are applying here, remember the ground is frictionless. So two possibilities are there. Okay, one thing that can happen is that when we apply the force from this side, okay, this and this have a common acceleration. Acceleration of A is equal to acceleration of B. Okay, and basically in that case, what is happening? There is no slipping between A and B. Okay, so basically A and B move together. Okay, because static friction between A and B prevents slipping. Okay, that's one case which is possible. Or the second case which is possible is that because enough friction is not available to us, so what is happening is when we are applying this force, B starts to slip from under A. So B has an acceleration which is greater than A's acceleration. A will also accelerate because friction will act on it. Okay. So acceleration of B is greater than acceleration of A, that is slipping occurs between A and B because static friction is not enough to balance or to prevent slipping. Okay. So also further, if we understand in this case, the individual free body diagrams of the two blocks will be such that while we are applying a force like this on this will experience a static friction backwards. This will experience a static friction forward, and they will have the same value of acceleration. And static friction of less than equal to mu n acts on. Whereas in this case, if you look at the free body diagram, the second case, because there is slipping occurring now. So what type of friction is going to act? Kinetic friction is going to act. And that will give this block an acceleration greater than acceleration of B. And kinetic friction equal to mu n will act. Okay. So there are two possibilities. Now again, it depends on the value of F. Which of the two possibilities is occurring depends on the value of F. So basically, depending on F and also maximum friction available, there are two possible situations. And those possible cases are these things. So we have to determine which of the two cases is occurring. Okay. So just take this down first, then we'll discuss again which is happening where. And basically how to determine whether slipping will occur or the two blocks will move together without slipping and with static friction acting between them. So this is a more challenging type of question than the previous ones we have seen, because here there are two moving blocks and friction acting between them. So to cover the condition of slipping versus non-slipping, a bit more analysis is required compared to the previous questions. Kunj, actually in the first case, they will have common acceleration. Let's understand why. So, we have to actually, first of all, develop some method for understanding whether or not common acceleration is there, which of the two cases is occurring. So what we do, whether we are looking at part 1 or part 2, whatever the value of force, we always have to first rule out whether there is slipping or not. Okay. So in the first case, the force was 30 newtons. Okay. And remember the masses of the blocks were 5 kg, 15 kg. Coefficient of friction was 0.2. Okay, these were all the things that were given. So anytime we will start a problem like this, now we will start by assuming that there is no slipping. Assuming no slipping between the blocks. That is, acceleration of A is equal to acceleration of B is equal to A, suppose. Okay. And the friction is static friction, so it's less than equal to mu n. Now let's first calculate this value of mu n. So for that, let's just understand the free body diagram of A in terms of vertical forces, so that we are clear about normal reaction. Okay. And then this normal reaction acts on B downwards. There's normal reaction n prime. But the friction between A and B, which depends on which normal reaction, the normal reaction between A and B. So that is this n over here. So you can see that n is equal to weight of A. So that is equal to 50 newtons, taking G as 10. So mu n is equal to 0.2 into 50 or 10 newtons. So this value here is 10 newtons. Okay. Now, of course, we are applying some horizontal force here. So there's some kind of friction acting here and some kind of friction acting here. Now, if we make this assumption that the friction is static, okay, then what we can do is, since A and B move together under this assumption, okay, we can make a combined free body diagram of A plus B. And in that combined free body diagram, is moving as one solid single block on a frictionless surface. So it's very easy to calculate how much that common acceleration should be. Okay. So that common acceleration should be force divided by total mass. So that is 30 divided by 20 or 1.5 meters per second square. That should be the common acceleration. Okay. But also from the free body diagram of this block A, now also from A's free body diagram, which you can see above, as far as horizontal forces is concerned, only one force is acting, static friction, and it should have an acceleration equal to this A. We have from this, okay. So how much static friction is required? 5 into 1.5. So that is 7.5 newtons. Now we can check that 7.5 newtons is available to us because this maximum is 10 newtons. Okay. So therefore our assumption is correct, because maximum friction was up to 10 newtons. So to prevent slipping, only 7.5 is required, which is very much available to us. That means our assumption is correct. Okay. So therefore our assumption is validated, and we can say that this is what is ultimately happening in the first case. So since the required friction required to prevent slipping, okay, this value is less than the limiting friction. Okay, so that is only 7.5. The limiting friction is 10. So that means our assumption is correct. Assumption of no slipping is correct. Okay, and acceleration of A will be equal to acceleration of B will be equal to 1.5 meters per second square, and static friction of 7.5 newtons acts between the blocks A and B. So this is the final conclusion in this particular case. Okay. So note this down, and now you can apply the same kind of method to work out what's happening in the second case. In the second case, the force was increasing from this value we had taken of 30 newtons to 50 newtons. Okay, second case, everything else is the same, but increase the force to 50 newtons, and see now what is happening in this case. You apply the same method. So Kunj, hope you have understood why the first case the accelerations are same. Because see, if you assume that maximum friction of 10 newtons is just acting, the result you are getting that acceleration of A is more than the acceleration of B. But you can think yourself that logically that is not possible, because we are applying the force, external force is acting on B. Block A is sitting on top of it. So how can it happen that on applying the force to B, A starts slipping faster and B is slipping slower? ऐसा तो नहीं हो सकता ना? So either they will have common acceleration, or B will be the one having more acceleration, A will be the one having less acceleration. Okay, so let's understand now. In the second case, if we start with the same assumption that let's assume there is no slipping, the conclusion we'll come to is that we don't have enough friction available to support the assumption. In the second case, again, on applying the force of 50 newtons this time, again, if we start with the assumption of no slipping, that is A1 is equal to A2, and static friction of less than mu n is acting. We'll see that for the combined free body diagram, the common acceleration will come out to be how much? Under the assumption that 50 newtons force is acting, this common acceleration will come out to be F divided by total mass, come out to be 2.5 meters per second square. Okay. Now shifting to the free body diagram of A, from A's free body diagram, we can see that on the block A only friction should be acting, and they should be giving it this acceleration of 2.5 meters per second square. So we can see that static friction from this is equal to this much. So 5 into 2.5, so 12.5 newtons of static friction is needed. I can see that this assumption is not possible because maximum static friction was equal to 10 newtons. Okay. So the required friction required for no slipping, that is becoming greater than the limiting friction available. Okay, so that means my assumption is wrong. Therefore, the assumption of A1 equal to A2 is incorrect. So if this assumption is incorrect, then what we have to do next, we have to understand that this now automatically implies that A1 will not be equal to A2, and kinetic friction Fk equal to mu n x. So we'll make new free body diagrams, and from those new free body diagrams, we'll understand how much will be the individual accelerations of the blocks. Okay. So just make a quick note of this part and make sure you understand up to the point where we have seen that the assumption of common acceleration is failing over here. Okay, then we'll proceed ahead and see what to do when that assumption fails. Yeah, thank you. Tell me what's happening. So once we know this assumption is failed, we'll make separate free body diagrams because they are having separate accelerations. Yeah, what should not be equal, Itanshu? You can see kinetic friction is acting between them. So they will not have equal acceleration. They will not have equal acceleration. So that's what I said. So that's why the answer is not correct. Now we have to work out the new answer. Okay, so this assumption is already failed now. So A1 will not be equal to A2. The acceleration of A will not be equal to acceleration of B. So they're having different accelerations, and this is how the free body diagrams are looking. So F minus kinetic friction is equal to mass of B into acceleration of B. So this equation will now tell me how much acceleration of B is. So F minus, now kinetic friction will be how much? It will be equal to coefficient of friction into normal reaction. So that was 0.2 into 10 newtons. You can see that it will be, sorry, 0.2 into 50 newtons. So it will be 10 newtons. Okay, so the kinetic friction is 10 newtons. So, and mass of B was 15 kg. So 50 minus 10 is equal to 1580. So acceleration of B will become 40 by 15 or 8 by 3 or 2.67 meters per second square. This will be the acceleration of B. And acceleration of A, for A you can see this is the equation, for B with this. So friction is equal to mass into acceleration. So that friction is 10 newtons. Mass is 5 kgs. So acceleration of A will be 2 meters per second square. Okay. So what is really going to happen is that eventually A is going to fall off because you're applying this force. So now acceleration of B is more than acceleration of A. Okay. So after some time, your B would be somewhere here. If you're continuously applying the force, and A would be like this, and A would then slip off. But we are just concerned with the acceleration initially when we start applying the force. So that will be like this. Is it clear, Hitanshu? Okay. So in the case of 50 newtons force applied, they will have these different accelerations. Okay. Now let's see this similar kind of thing, but with the difference now that if we apply the force on the upper block. So let's look at a fresh example. Yeah, I said that look at a different example with force now applied on the upper block. So let's say this is M1, this is M2, and this is a smooth surface, this is a rough surface. Now again, same kind of situation, but to start the motion, we are applying horizontal force on the upper block instead of the lower block. Okay. So both blocks are initially at rest. This time I'm taking M1 to be equal to 4 kilograms. M2 to be equal to 6 kilograms. And the coefficient of friction to be 0.5. Okay. Obviously take G as 10 meters per second square. So find their accelerations if F is equal to, let us say, 20 newtons. Okay. So again, this problem we will do with the same method, but keep in mind that the friction acting on M1 will be backwards this time. And because we are applying the external force on M1 forwards, so there will be friction acting like this on M1, whereas on M2, the friction will be like this. Okay. So you can see that if A1 is equal to A2, that is no slipping, then the friction should be static friction. Okay. So it should be less than equal to mu m1g, or static friction should be less than equal to 0.5 into 40, so 20 newtons. Whereas on the other hand, if A1 is not equal to A2, so basically A1 will become greater than A2, slipping is occurring, then the friction is kinetic in nature, and kinetic friction equal to mu m1g, or kinetic friction of 20 newtons will act. So again, to solve the problem, to find A1 and A2, what we'll do is we'll start with the assumption that is, there is no slipping. Okay. So make the combined free body diagram. On that, okay, so just start with this, people. Okay, so this common acceleration, we assume it. Yes, that's correct, Kunj. We will get a common acceleration here. So for the value of force of 20 newtons, you can see that this acceleration will be 20 newtons divided by combined mass of 4 plus 6, 10. So 2 meters per second square. Okay. Now we have to see from M1's free body diagram. Oh, sorry, this time you see M2's free body diagram, because friction alone is acting on M2 now. So from M2's free body diagram, you can see that the friction acting will be M2 into A2, which in this case will be M2A. So that will be 6 multiplied by 2, so 12 newtons. So how much static friction we require? Only 12 newtons. Whereas how much is available? Up to 20 newtons. So this assumption is correct. So since the static friction is less than equal to mu n, therefore assumption of no slipping is correct in this case. Okay. So they will have a common acceleration of 2 meters per second square with static friction equal to 12 newtons acting between them. So that becomes the answer for this question. Okay, so this is a very important category of questions called the two block problems. Okay, and this is the method of solving. Whether you're applying the force on the upper block or lower block, the common way of solving, the logical concept that we use is you start with the assumption that they are having common acceleration, check out how much that acceleration is, check out how much friction is required, and then test the value of friction against the limiting friction. So here for common acceleration, the friction required was 12, whereas the limiting friction was 20. So your assumption is correct. Whereas if your assumption fails, like in the previous case, then you have to again change your free body diagrams from the combined ones to the single FBDs, taking different accelerations and kinetic friction. Okay, so we are coming close to winding up friction now. Next lecture, we'll be discussing mostly questions and doubts. So please try to finish up maximum questions from HC Verma and your module, and be prepared with the doubts in the coming lecture. And we'll finish friction, and after that, the next chapter we'll start with will be work, power, and energy. So that's it for today's session, people. Wish you all the best. In next chapter, we'll be doing IU should be work, power, and energy, okay, which includes the work energy theorem. So you can start reading a little bit ahead for that also. So anyhow, that's it for today, people. Wish you all the best.